It's good.
Okay. Just like Thailand, I don't want to spend too much time on the facts or the common knowledge. I just want to share my opinions on the same topics that already discussed. History of the noise is also the history of the science, according to Cohen. And I believe the reason for that is because the universe is much more random than we usually tend to think. And we can actually see that throughout the paper. Scientists were just trying to solve their problems and answer the questions they had. And it just turns out to be that answers lie on the concept of randomness. And it's no surprise that we come across with the noise while we are dealing with that much of randomness. The first stop of that journey is the atom debate, as Gwen said. And the first half of this debate, the foundations of the atomic idea, is repeatedly discussed, and I don't want to spend too much time on that. I just want to point what Gwen said about the Democritus, which I find amusing, that he said he was no scientist, and he was just many other guys making guesses about the nature of the world, and it just happens to be that he got luckier and made a little bit more accurate prediction about the nature of the world. The second part, on the other hand, about the atom debate is much more important since it has a lot of concepts that directly relates to Einstein's work. So first, Clausius made a new understanding of the heat. He said that the heat flows like just like another fluid. And he also defined the temperature as we know since the high school. But more importantly, he said that movement of the particles shouldn't be described with certainty. Instead, it has to be described with a probability. And I think this is the first time we got met with the idea of the probability in the thermodynamics. And he did some entropy stuff too, but I won't be going deep into that. What Clausius was doing was good, but it wasn't enough. Maxwell added that the velocities also have to be random as well. And he made a distribution about that, which we call Maxwell-Boltzmann distribution. As you can see here, according to Maxwell, different noble gases have different distributions at the room temperature. And Cohen says with the Maxwell and Clausius, modern thermodynamics were laid off. And what was Maxwell did was good also, but it wasn't enough either. Boltzmann questioned how that probability of the movement and the location of the particle evolves, and he came up with the transport equation, which defines the movement and the speed of the particles in terms of the collision. And he also studied that entropy which Clausius brought, and it's important topic that anti-atomists use quite often. There were such people like anti-atomists. It might seem a little bit silly from today's perspective, but they had quite solid arguments back in those days, since a lot of people like Boltzmann and Clausius building a new understanding of the probability and atomic idea, but they had no clear evidence on that topic actually. And we can see that when Loschmidt, I guess, comes with a counter argument about entropy, but Boltzmann couldn't come up with a better solid argument. And Cohen puts a word like that if one bases their mathematical equations, which I won't be read that, but it's important to listen them since we are building a new terminology about that. And if there's some mistake, this all goes to garbage. And after that, we already discussed about the Brownian motion, which is a random movement of the particle in a fluid. And we also know that Robert Brown isn't the first one who observed that, but rather he studied it very systematically. So now we call this motion as Brownian motion. At first, he believed that the reason for that movement might be related with the somewhat a life force, but that wasn't the case. After some experiments, he showed that that wasn't the case. And he was just a botanist, and he was aware of his limitations, his lacking scientific background. And he also stated that in one of his papers, and I find this great since this level of awareness is just amazing. Until now, we see the development of the both atomic idea and the probabilistic view. These were all important because Einstein base his very work on that concepts. And what I want to point out about Einstein is his motivation and the way of working. As Kuan said, and as we read, Einstein wasn't interested in the Brownian motion or the randomness behind that motion. He was purely motivated to relate these topics into existence of the atoms. That's why he studied this motion. And I believe this might explain how he managed to pull out 3 groundbreaking articles about different topics in just 1 year. If you think like that, he might. It's no surprise that Einstein come up with these 3 articles. And he did some autocorrelation and the Brownian motion, but we discussed these topics earlier in the homework, so I won't be going deep into that. And there were analogy between the Brownian motion and the elephant and the mosquito in the paper, but I watched the similar analogy between penguins and the iceberg. It's much simpler. It just, if you think like the elephant, not elephant, the big particle, the pollen as the iceberg in this case, you see the movement of the iceberg. It might be caused by the penguins around it. But if you go far enough, you can see the penguins actually. But you know there are penguins around that iceberg. So you might deduce the existence of the penguins just by looking at the movement of the iceberg. And it was written after the Langevin part, but I don't know if it's related with Langevin. I just put his picture of here. After that, our next stop is the finance. At first, I find this a little bit odd because after all this scientific stuff like chemistry or physics, but I think it's odd to find it out. Bachelier did a great job pulling out the mathematical concepts and carrying out this to area of finance. But it was no surprise since he was a student of the Poincare. After learning he was a student of the Poincare, I lost my interest a little bit since what are we expecting from the student of the Poincare, right? I couldn't find the perfect phrase to put it, but it's somewhat related to academic elitism or something like that. And we also see the Bachelor's formula of evolving probability. It might be related with one of our homeworks, which we convoluted the probability densities of 2 functions. So the engineering and
just a second, 1 minute.
Okay.
Eren, go back to this previous. What do you mean? Yeah, he was a student of Poincare and Poincare or Poincare. I don't know how it's spelled. Say it again. What you were thinking, expecting, or what did you say?
I said I aware of his genius, but after learning that he was a student of Poincare, I didn't know that before. After learning that he was a student of Poincare, I lost my interest because the great minds, great minds or the great ideas come from the near of the previous great works. I know that. But it's just how the world or the academia works in general.
I see. You were thinking like this, like out of blue, he came up with those ideas. But later on, when you learned that he was this student of Poincare,
not entirely
Poincare or whatever, then I see you are not impressed.
Not entirely out of blue, but he was a student of the Poincare, one of the greatest mathematicians.
Okay, all right, I understand. Go ahead.
This topic, engineering and noise, and especially the electrical engineering, is a quite vast topic, and I won't be talking too much on that, even though I want to speak about the Maxwellians or the vacuum tube. All I can say that with the electrical engineering especially, we see that noise become a more prominent figure, but still we don't deal the noise itself. We don't just try to understand how noise works. Yeah, we know how it works. We have some methods to analyze it, but mostly we just trying to get rid of it or make some stuff to get rid of it. So I think it's a little bit rude to treat the noise like that. And also there are so important topics like shot noise or thermal noise, which is discussed in the paper, but also I don't have any time. But unlike the electrical engineering, astronomy puts the noise at its core. With the spectral lines or that cosmic background noise, we see that the main interest of the scientists becomes the noise itself, since the measurements on those related areas with astronomy very small, and when the measurements are small, the fluctuations around those measurements become important at the same time. So it is possible to define an element with its absorption or the absorption. What's the other one? Our emission wavelength across the spectrum, or some guys back in Bell Labs come to understanding of the expanding of the universe. I know that's not directly related to noise or that kind of stuff, but I think it's just amazing that we started with the atoms, then go across that atom thing, and now we are dealing with this universe. I just think it's amazing. There's also a lot of concepts like Fourier transform or self-similarity in that paper. Also some stuff that barely discussed or not discussed at all, like Mandelbrot, which Tayfun Hoca mentioned earlier. This topic is also very crucial to understand the randomness or the noise, but as I said, it's barely discussed, and I don't have much time to discuss. I hope we talk about this later on. And at last, we have quantum and new understanding of the randomness and noise. Cohen actually explains the quantum mechanics a little bit, and very basic actually, and it was good. I just want to say this paper published in 2005, and just recently in 2022, a Nobel Prize to 3 physicists is about that true nature of the physics that Einstein and Bohr discussed almost a century ago, which Einstein said to Bohr, God doesn't play with dice or something like that, and Bohr replied, don't stop telling what God to do. And from not that, just last year we learned that gods do play with dice. Conclusion. Overall, I think this is not entirely history of the noise, but it's also a story of the transition. We see the struggles while scientists making that transition from their deterministic point of view of the nature through that more probabilistic or the random point of view. And it's also fun to read. It's fun to read all this magazine stuff that Cohen talks about the scientists, and it's also gave me a better understanding of the randomness overall.
Okay, good work. I like the drawings very much, and I want them.
You want